store will actually store all your information by column instead, physically on disk. It basically stores each column in a big hash on disk. And the way it stores it, you basically get null columns for free. It tends to be able to store the data a lot more efficiently. It's not uncommon to take a data set out of RDBMS, put it in a column store, and get 5x, maybe 10x compression, or less storage space out of that. It tends to be very schemaless. If you want a new column, go right ahead. Be my guest. If you want 10 new columns, go ahead. It'll handle it. As a matter of fact, some of them, even just referencing a new column, will create that column and stick the data in there for you. That can be very compelling for certain companies or certain applications. Data is very non-relational. It tends to store the information in a table form. As a matter of fact, Google's product, Google's column store is called Big Table, and they mean that literally. You're talking 10,000 or maybe 100,000 columns across by 100 million or 1 billion rows. And the problem that they were trying to solve is how do we take that much information and be able to handle it efficiently. And so basically they take all these hashes, they chunk them up, spread them on different machines, run MapReduce, and they, it's what we got today to reach your Google searches. So the non-relational data tends to be very denormalized, but since your columns, you basically get no columns for free, you can have 10,000 columns, but just write a handful of it. A handful of those columns would be very efficient. And you can specify when you read back what columns that you want, very similar. Very easy sharding, it's all built in. Asset compliance kind of depends on the product. Some support it, some don't. So some of the products in this space are Google's Big Table. There's a 2006 paper, so if you go out to Google and search on Google 2006 Big Table, there's a really nice paper there that you can read that gives you a lot of background. It's actually, it's fairly short. I think it's only 10 or 15 pages or something like that. Really excellent reading if you're interested in any of this stuff at all. Hadoop and HBase. Hadoop, I'm sure you guys have heard that around. It's an Apache project here. It's actually part of a very large ecosystem. Hadoop is slightly different than some of these other products in that at its base, it's a distributed file system called HDFS. So what Google said is we want to take the file system itself and make it scalable. And then we can put anything into that file system and it will get that scalability as part of the equation, right? The Hadoop part of it is actually the MapReduce part of that equation. And HBase is a column store database that sits on top of Hadoop and HDFS. So it's a little bit more complicated to install and run. On the plus side, this will scale. I think the limit right now is about 4,000 nodes. So if you've got really big scalability, this will do it. I think they're working right now on upping it to about 8,000 nodes. So somebody needs that many. Cassandra is also very popular. It's written by Facebook for their needs. They went out and put that together. And one of the very cool things is you've got LAN and WAN replication out of the box. It's very cool. Hypertable, another product. They kind of went the route with a pluggable DFS, which is a distributed file system. So it supports HDFS, and there's a couple others that are out there. And then it has HQL, which is Hypertable Query Language, which is one of those SQL-style query languages that some of these support. Vertica is actually quite interesting. It's one of the few commercial products that are out there. It's owned by HP currently. It's based on an academic paper called C-Store. You can go out there and look for that if you're interested in. One of the really neat things is that it has a full SQL implementation built on top of it. So any of your business intelligence tools, or a lot of tools that we're used to working with, JPA and all that stuff, will work right out of the box with Vertica. But keep in mind that these tend to work much better in data warehousing style applications than transactional style applications. And then up on the cloud, we have Amazon SimpleDB, which you can go out and use at a very good rate. courtesy of Amazon. So moving on to talk on to document stores. So a document is essentially a blob, right? You have, in this case, you have either a key value, or some of them will prepend a bucket. So like Amazon's S3, you have a bucket, a key, and a value. So the bucket gives you some namespace in availability, to keep your stuff away from somebody else's stuff. The keys are essentially opaque. It's just a byte array, and your value is also the same. So it doesn't have any particular knowledge of what your information is. It's just, you give me some blob, and you give me some reference, and I'm going to put it on this somewhere for you, right? That's basically how they run. Very easy to shard. I mean, the units are very small. Consistent hashing here is a technique where, if you've got, say, 5 nodes and you add node number 6, you don't want all 6 nodes to reshuffle data. You only want the adjacent nodes to shuffle data around. If you have 1,000 nodes, you don't want all 1,000 nodes to all of a sudden start shuffling data because you added or deleted a node. So consistent hashing is a way of dividing up the data to make the least movement of that data possible. A lot of times, it's generally ACID compliant, but just for that particular get or put, they're atomic. SQL kind of really doesn't apply here. I mean, it's a hash. It's hard to layer SQL on top of a hash, so you can do it anyway. And then on our implementation side, we usually get access to this by a map, or a lot of times a custom API that But again, you're just doing keys and values. But the interesting thing you can do with this is your value can be anything, like say XML or JSON. So a lot of times if you want to use this, for being able to do something a little bit more familiar with, you store everything in JSON format, and then when you read that back out, you can deserialize that into Java objects and make great use of it. So some of the products in this space, Amazon has Dynamo and S3. Dynamo, actually Amazon wrote a paper on that too. That's another interesting one to read. React is one of my personal favorites in this space. Cap tunable, and it actually has built-in MapReduce, which is big data processing as part of the product itself. So some of these other ones like Mongo and Couch, you need to rely on Hadoop to be able to process a lot of the information there. Both CouchDB and MongoDB are very popular. Couch gives you full ACID support plus a REST API, which is quite interesting. So you can just use curl on the command line and play with these products. MongoDB has really strong indexing and query support, which can be very important. Voldemort, which I think was LinkedIn. I believe that's correct. They wrote that. Java-based, and they have a pluggable serialization model. And then MySQL actually goes into here too. There's at least one company I know of that's actually taking the MySQL store, stripping most of all the good stuff away, all the indexing and the schema support, basically just doing key value access out of it, and trying to do that very quickly. So, matter of fact, Facebook is really big into MySQL. They started there, and they still use MySQL a lot, but they tend to use it in more of a NoSQL fashion. So these tend to live mostly in consistency and availability realm. I missed something here. Sorry. Okay, so we're going into memory stores. So memory stores, again, the data model is essentially the same. It's a key value store, but the purpose is the scalability model. Those kind of things tend to be very different. Most oftentimes these are used as very high-speed caches, and they have a real focus on, how do I work this data as fast as I possibly can. So actually a lot of the products do partition very well, but it just depends on a particular implementation. Some are local only, like Memcached